Hello everyone and welcome back to my channel. So today we are going to start a new series on Kubernetes where we are going to cover everything from scratch to advanced, that is from zero to hero. So today we are going to start day 1 with understanding Docker fundamentals. See, Kubernetes is a container orchestration tool. So, in order to understand a container orchestration tool, it is important that you understand containerization concepts as well. Since Docker is a containerization platform, it is important that you understand it in order to um, master Kubernetes. Okay, so that is why we are going to first understand Docker basics in this particular video. So if you have very good idea about Docker, then you can definitely skip this lecture. Okay, so in this video, what we are going to do is we are going to understand what Docker is. Then we will try to understand why Docker is important and why is it actually being used. Then we'll try to understand some Docker concepts, followed by Docker architecture, and finally we are going to Dockerize an application. Okay, so the application is a Node.js application which we are going to Dockerize. So if you want me to Dockerize any other application, you can just provide a link of that application, and in the next video we can show you how to Dockerize it as well. Okay, but in this video we are going to Dockerize a Node.js application. Okay, so without wasting any time, let's get started. So basically this Docker works on the principle of virtualization. So basically, a virtualization is a process of creating a virtual or an abstract version of something. So most commonly, it can be a physical machine with a particular operating system, storage, as well as hardware. So it basically allows to create multiple environments. Multiple environments on a single physical machine. Okay. So, few examples of virtualization include virtual machines, containers. Okay, so these are few things that we need to understand. So, basically, in order to understand containers well, you also need to understand virtual machines. So, let's try to understand what problems do these virtual machines actually solve. Okay, so let me scroll. Over here, you can see that over here there are multiple virtual machines created on top of this physical machine, right? So basically this is possible due to this particular software known as hypervisor. So what does this hypervisor do is it distributes the resources or allocates the resources of the physical machine to the respective virtual machines, right? It also helps generating a specific guest OS for that particular virtual machine. Okay, so this is how a virtual machine is created. So basically, virtual machine is nothing but a software emulation of a physical machine. Okay, that runs an operating system as well as applications similar to what a physical computer does. Okay, and hypervisor is something that plays an important role in virtualizing it, right? Now, what are the problems that are solved by the virtual machine? Like, why is it required? in the first place? Like, we already have computers, then why do we need virtual machines? So the most important thing is that there are few problems with there were few problems with the physical server. Now, what are the problems? So the first thing is that resource underutilization. Now, what was actually happening? So basically, it was a bit difficult to run or execute multiple applications on a single server because of the conflicting dependencies. So, what was happening is that one application was allocated to one server. So, what was happening? The rest of the resources of the server were remaining unutilized, because of which it was like inefficient usage of the resources was happening, right? So, this gave rise to the idea of virtualization or virtual machines, wherein it could be solved by creating multiple such virtual machines which can be allocated to the respective applications, and they could be utilized accordingly. So instead of having that one application on that particular physical machine, we could uh, deploy multiple applications on multiple such virtual machines on the same server, right? The resources are the same. We are not spending extra money on it, right? So, this was the benefit, or this was the problem that was solved using virtual machines. The second one was again one app, one server model. Again, the same thing, which was very much inefficient approach, right? Which made the resources underutilized. The other problem was like poor isolation. Now, if let's say, even if they deployed multiple applications on the same server, like most of you must be saying, like instead of going for multiple virtual machines, if I deploy multiple applications on the same server, it should work. But the problem that it gave was that if one of the applications, like let's say, this is my virtual machine, sorry, this is my physical machine, on top of which I have two different applications, app 1 as well as app 2. Now, what happened is this application crashed due to some problem suddenly. So, it made few changes on your server as well, on your underlying physical machine, which also crashed the other applications that were running actually fine. There was no problem in them, but still they stopped working. So, because of this kind of poor isolation, the applications could not run properly. So, this gave rise to another reason of creating virtual machines for the respective applications. Okay, again, for creating multiple environments. Okay, so you know that in our IT industry, we have multiple environments, right? Where we do development, we do testing, uh, we deploy everything on production environment, which is directly associated with a client. So this is how things work in an IT industry, right? We first plan the software design, then after that we actually design it, right? Then after that we code it. We code, like the developers are asked to code and test in the development environments. Then again the testers, they make use of multiple test cases and eventually test the application so that it won't give any problems when it is actually deployed on a prod server, right? Then we deploy it right? Then after that, we kind of monitor the deployed applications. Then we check or review, right? We take the feedback from the customers. If we find any problem, we again repeat the same process, right? So this is all about the SDLC life cycle that occurs in an IT industry. So in this case, we make use of multiple environments. And in case of physical servers, in case of physical servers, the problem was that it was very much difficult since there was a lot of costing involved in it. For having a particular server, we need to kind of set up, we need to configure that particular system for that specific application. So there was a lot of things involved in configuring a server. And for each environment, if we consider a different server, it was a long, hectic process, right? So, in order to make it a bit simpler, what we could do is we could just have one physical machine and we can create multiple such environments using virtualization approach, that is with the help of virtual machines. We could create three or multiple servers which were independent, which were completely isolated from each other, which had their own independent operating system, right? So this gave a bit convenience as compared to the physical server. Also, a lot of cost was saved, right, with this particular approach. So it gave rise to the solution, that is virtual machines. I hope it is clear till now. Okay. So, this was a brief about virtual machines. So, I hope it is a bit clear. But one more thing I would like to say, that these were the problems. Now, let us try to understand like what is a virtual machine. So, basically, you can see there is a hypervisor, right, with the help of which the machines are getting different resources, like the specific resources are getting allocated to these specific virtual machines. They also have their guest operating systems, right? So virtual machines have their own guest operating systems. They are more isolated, since if one of the application crashes, let's say this application on this particular virtual machine has crashed, it has got nothing to do with the other two applications. They are still in the running mode, they won't be affected at all. Only this application or this virtual machine is going to face the problem that has been arised over here. Okay. So this isolation was provided. This virtual machine simply act like an individual physical machine, okay, with a limited resources. That's all. So the resources that are underlying, that is the physical server resources, are not shared. They are specifically allocated. For example, if the this physical machine, it has got 16 GB of RAM, okay, and you allocate 4 GB of RAM to this particular virtual machine, another 4 GB to this, and another 4 GB to this. So the RAM that is being used by this particular virtual machine has got nothing to do with the RAM that is being used by another virtual machine. So they are completely isolated from each other. And they are specifically, this 4 GB is only and only allocated to this. Even if the few resources, let's say 2 GB, are being utilized and the other 2 GB is idle, it is not in usage, still it will be in the idle state. It will not be used by any other virtual machine because it is specifically allocated to this particular virtual machine. Okay. So this is all about virtual machines. Okay. Now the next thing that we will discuss is about containers. Okay. So basically, in order to understand the importance of containers, let us first try to understand how virtual machines solve the problem and what was the problems that were faced by virtual machines itself. Okay, so basically, initially, the companies used to have their own data center. Within that, they used to have multiple physical servers, right? This was about physical machines. Then, with the concept of virtualization, a new concept called virtual machines was developed. So, in this case, what happened is you had the same data center, okay, within which you had your physical servers, but for running multiple environments, you were making use of virtual machines, which were deployed on the same physical server, right? So, this is our VM1, VM2, and VM3, right? So this is our data center, this is our physical server. Okay, now what happened is, like, we understood the software development life cycle, right? So in that case, uh, we were making use of these virtual machines for different environments, for example dev, then test, and then prod, right? Now, when the developers used to code, okay, they coded on, let's say, on this particular machine, okay, and they executed the application is definitely working fine over here, okay. They wrote the code, they ran the code, and the application is in the working state, well and good, so it's working on this machine. Now, the next thing, in order to test, they would need to push this code on this particular machine of test environment, right? So, the configurations, like in order to run any application, there are few configurations that are required. For example, let's say network configuration as to that particular application should run on which port. Second thing is about, let's say, dependencies. For example, if that code or the application is running on Python 3.2, okay, then also the libraries. So there are multiple libraries within different languages, right? So these libraries are required in order to execute that application, right? So these need to be imported. Next thing is about environment variables. So the developer had configured all of these on the dev server. But at the same time, he has to configure everything on the test server. He has to configure the same thing on the prod server as well, right? The same thing needs to be configured on all the servers so that the application functions well. But this is a time taking process, right? And this might give rise to multiple conflicts because within dependencies, like within Python itself, there are multiple versions, right? So if there is any problem, or if any other version has been installed on any other server, it is going to give dependency conflict, right? So the application won't be executing as per the requirement. Like how it was working on dev environment, it won't be working on test because of minor differences. So it might seem simple, right? You can say, like, if the tester or the developer, they are not communicating properly, or if they can just communicate and just share all the details and then install everything, that's perfectly fine. But in case of smaller applications, it's fine. But in enterprise level applications, the complexity is a bit high. So many libraries are involved, so many dependencies. So all of them might create a lot of issues while deploying across multiple environments, right? So in order to solve this problem, the problem of it works on my machine, right? So this was the problem, right? This is a most popular meme. Most of you must have already seen this, right? It works on my machine. Developers used to say it is perfectly working on the dev environment. Then the testers used to say, no, 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 it is not the problem with the machine, it is the problem with the code. Please check the code. So there was a conflict between people across uh, developers, then operations people, right? So, in order to solve this problem, the concept of Docker was born, wherein what is said over here, then we'll ship your machine. Okay, so the whole machine is being shipped now. How? I'll explain. And that is how Docker was born. So, let us try to understand that. So, basically, what happened in case of container is that containers is a standard unit of software that packages applications along with its dependencies to execute or run across multiple environments. Now, what does this mean? So, all the network configurations that we defined, right? Network configurations, the dependencies, the environment variables, as well as the libraries, everything packed along with application plus all of these, right? Packed within a package known as container. You can just imagine it as a tiffin box or your lunch box, right? So, your box over here, you can just fill in all the requirements that you have in that, right? You have roti, sabji, and whatever your rice, dal, etc. in this particular box, and you can carry it anywhere in your office, in your school, right? On your picnic spot, anywhere you can just carry this lunchbox and it's perfectly fine. Similarly, what happened with container is that everything is being packaged in this and you are just deploying it across multiple environments. How do we do that? So basically, there is a concept of image. You create with the help of application, you create a Docker image out of it, you store it somewhere on your repository, okay, and you just pull this image across multiple environments and you execute it, and that's it. Okay, so this is how the problem of not being able to install the correct dependencies across multiple environments was solved with the help of Docker containers, right? So, in this way, containers were born, and this is how it completely changed the life. But it doesn't mean that virtual machines are not used. Virtual machines have their own use case, whereas containers have their own use case. So basically, you can say that in case of VMs, you generally use them in case of legacy applications. Okay, you can use them where isolation is the top priority. Why? Because isolation in case of VMs, virtual machines, is more stronger as compared to the containers. Okay, and third thing over here is multiple op- or we can say diverse operating systems can be used across virtual machines. So in these use cases you can definitely go for virtual machines. Okay, whereas in case when do you should use containers, you should use containers in case of microservices. Okay, you should use them when portability is your top priority, since containers are highly portable as compared to that of virtual machines. Virtual machines are very heavy, right? Whereas these containers are very much lightweight as well, and hence easy to share across multiple environments. So this is also in case where you have when you want to have resource sharing. Why? Because in case of VMs, you can see I already explained that resources are specifically allocated to that specific virtual machine. Whereas in case of containers, it is not the case. I'll explain that as well, okay? So basically, you can see this figure or diagram over here, right? So over here, you can see that there is an operating system over here. This is the physical machine. Here you can see the Docker engine. You can see the Docker or any container engine. And on top of it, you don't have guest OS over here. Why? Because they are virtualized across the operating system. There is no hypervisor over here, which is going to allocate specific resources to the specific virtual machine. Whereas over here, the resources are being shared. For example, if this particular application over here, which is running in this particular container, is, let's say, stopped for some time, all of them are in the running state, but this one, after running it for a while, I stopped it. Now, the resources that were used by this particular container can be used by other container as well. So there is less isolation as compared to that of VMs. So in that case, where we want the resources to be shared across different environments, then in that case, you can definitely go for containers. Containers have multiple benefits. You can definitely read them. Whatever I feel is important has been covered in this particular lecture. If you feel any doubts, you can definitely ask me. Okay, so this was about virtual machines as well as containers. I hope it's clear. Now, most of you will be questioning, ma'am, you explained everything related to virtual machines, you explained containers. Then what is Docker? Right? You are alternatively using container and Docker. So let me explain. So basically, Docker is a open source containerization okay, which helps in packaging your application along with its dependencies into a container which can be run across multiple environments. Okay, so this is about Docker. It is a tool with the help of which you can containerize applications. As simple as that. Okay, so this is what Docker is. If you understand what is containerization, Docker is very simple. It's just the platform that provides containerization, right? So it's that simple. So, okay, I hope it's clear. So, before actually doing it or actual implementation, let me explain few concepts to you. Okay, so there are few Docker concepts over here. Okay, so the first thing is the Docker file. Now, what is a Docker file? So, basically, a Docker file is a set of instructions that are being written in order to execute an application. Okay, now how to write a Docker file and everything, we are going to explain it. Okay, because it is not very much easy to explain it theoretically. Okay, so basically, Docker file, you can say it is a template. Okay, the name is Docker file itself. Okay, so along with your application, you will see this particular file, that is Docker file. It has got all the instructions like from, then copy, export, expose, sorry, then CMD, entry point, and so on. There are multiple such commands that are being used over here. So we will be explaining it while actually Dockerizing an application. So you'll get a better idea of it. So it's just a set of instructions, you can say, like in order to run an application, whatever steps one has to take, all those steps are being mentioned over here. Okay, so this was about the Docker file. Now, there is another concept, that is image, which I explained, right? Earlier, I have said about it. So basically, image is a template which again has got all the instructions or all the tools that are required for an application to be executed. So it is basically application plus dependencies, but in a template format. They are not in running state. Okay? They know class as well as object, right? Similarly, this class is a template, right? And the object is the actual instance of this class, right? Similarly, we have image over here, which is a template, and this object is nothing but our container, which is in the running state. Okay, so image is just the template which contains all of the dependencies and application that that would be executed once the image is in the running state. Okay, so when you create a Docker file, you build an image. When you build it, an image is formed. When you run this image, a container is created. So the next concept you must have already guessed is container. Yes. First is Docker file, second is image, then we have a container. So we already discussed what a container is. It is again a standard unit of software which packages the application along with its dependencies to execute the application independently across multiple environments. Okay. Then comes is registries. So registry is a place where you store your images. Store, or you can say manage your images. Store or manage your images. This is about your registry. Okay. So generally what happens is you have an application. Okay. You have your dependencies. What you do is you write a Docker file. Once you have all of these, you execute this command docker build. Then what happens is it basically searches the Docker file. If there is no Docker file, it won't execute. I'll try to mention the whole command. So basically, Docker build, whatever the tag you want to give, let's say my image, followed by if you put dot over here, dot indicates current directory. If you are not using dot over here, and you are just passing the path of Docker file, it still works because this is the path of Docker file itself. Okay, so it will search for the Docker file, it will build an image out of it. Okay, so after creating an image, when you do Docker run, let's say I put the port, let's say 8080. Okay, hyphen D, and the name of the image, that is my image. Okay, so this is my command. So after I execute this command, it will create a container. Okay, so that is the general flow. But in the enterprises, we don't generally um, run the containers locally because we don't make use of Docker. Why? That also I am going to explain you. Okay, why we just don't rely on Docker at the enterprise level. Okay, so basically we don't rely on it completely because of certain problems. Okay, so generally what is done is this image is being stored in the registries so that you can access it from anywhere. So how do you do that? So there is a command known as docker push. Okay, so you can push the image to this particular registry, which can be Docker Hub, which can be any private registry, which can be cloud native registry, AWS, Azure, or in AWS we have ECR, in Azure we have ACR. So whatever the registry that you are using over here, you can push that image onto this particular registry. Okay, and if you are on other machine, let's say this is happening in one machine and I'm on some different machine and I want this particular image, I can simply do docker pull. what it will do is, this is not the complete command. It's like docker pull and the image name. Okay, it will be pulling the image from the registry onto our local machine. Okay, so this is how there are few commands that are executed. Okay, so this was all about docker concepts. Okay, which were basic concepts. Now we are going to understand the docker architecture. So over here you can see that this uh, figure over here perfectly depicts the architecture. So basically there are three main components, and these are, first thing is docker client, second thing is docker daemon, and third thing is about registry, which I have already explained. So these two are new terms, the client as well as the daemon, right? So basically client is something that deals with the API requests that are being sent through the commands to the docker daemon. Okay, so it is basically a CLI. Okay, that is command line interface through which you send the API requests to your docker daemon, and it is something that is going to process your requests. Okay, so let's take an example. Let's take a complex example. Now if you execute docker pull, right, so what it should do is it should pull the image from the registry to your local machine, right? So what it will do is it will request the docker daemon. The docker daemon is then going to go to the registry, locate that particular image, pull that image onto our local machine. So this is how it works. Similarly, if you want to run, let's say the image is already present on your local machine and you want to run it. That is, you want to convert it into a container. Then in that case, let me use some other color over here. Okay. So for Docker run, it will again request the Docker daemon, right? Then it is going to find the image, right? And then it is going to create an instance of that particular image in the form of container. Okay, so this is how it works. Okay, so basically docker daemon is someone that will fulfill your API requests, and it will process whatever the requests are being sent to it from the docker client. Okay, so it's not much complicated. You just need to understand these three things, that is client, daemon, as well as the registry. Registry I have already explained, like it is a place where we store and manage our images, right? So now we are going to install Docker and then Dockerize an application. Okay, so we are going to Dockerize a Node.js application. So let me go to my AWS management console and create a virtual machine where we are going to execute the installation of Docker followed by the Dockerization process. So this is my AWS management console. I have logged in and now we are going to create a virtual machine, that is an EC2 instance. Okay, so I'll go and launch an instance. Let's name it as um, server. Okay, we'll select Ubuntu over here and launch an instance. So it is in the pending state. Let's wait for it to be in the running state. So over here you can see that it is in the running state. Okay, so it is 2 by 2 checks passed. Okay, so let's try to connect it. Okay, so we'll be connecting it using EC2 instance connect. So we are inside the machine now. Okay, so the first step that we are going to do is to install Docker. Okay, so for that we will be going to the documentation. Let's go to the Google and search for install Docker on Ubuntu. Okay, the first link that appears, you will be just going over there and so run the following command to uninstall all the conflicting packages. So if there are any Docker packages already installed, you can just go for this particular command and uninstall all of the conflicting packages. Since our virtual machine is totally new, we don't need it, right? Now, the first thing that we need to do is to set up Docker's apt repository. So I'll just go and copy these and paste it over here. And it's done. Okay. Once it's done, we'll be installing the Docker packages. All of these packages will be installed. Okay. Now let's check whether it shows. Okay. So now over here you can see that the client has been installed, but there is some problem with the daemon socket, right? So the permission denied while trying to connect to the Docker daemon socket. So basically this is due to the permission issue. We resolve it by giving the permission to this particular. Now over here you can see that the server. Okay, so the server over here is now available and it's available to serve our requests, right? Okay, so now we are free to execute Docker commands now. Okay, so how can we check that? You can just execute this command docker run hello hyphen world, and you can see that it is unable to find this image locally. So what it does is it pulls the image from this particular library of hello world. Okay, and this is something that is stored in the Docker Hub repository. So yes, I forgot to mention the Docker Hub repository. So basically Docker Hub is a public repository that is being provided by Docker. Okay, so anything that you pull by default is being searched from that particular repository of Docker Hub. Okay, so this is how the images are pulled and pushed publicly. Okay, so it first pulls it, and then this is a layer that gets created, and this is something, the status of downloaded newer image for hello world. Okay, so this is the status basically. and you can see this message hello from Docker. So this is basically hello world is an image, okay, and we are directly executing that image as a container, and this is what is the output of that Dockerized application, okay. So this is how it works. Now we already have one application, okay, so for that we have stored this in our Git repository. So basically I have created this Kubernetes 0 to hero repository for all the notes and references that you would be needing. So for day one, over here you can see that there are notes which you can refer to for your interview preparation. Also, these can help you, right? And then after that, we have this application that is a simple Node.js application over here, okay? And this is the package.json, okay? So these are the application files, whereas these are something related to the nodes. Okay. So what you can do is you can refer to this repository if you want to go through the notes that are being covered during our lecture. So let me clone this particular repository. Git clone, paste. So let's do ls, and over here is the repository which is being cloned. Now let's go inside of it. Okay. So over here we have readme .md. We don't have the uh, application files over here. So let's go inside day one. Okay. And over here you can see that we have the application files. So in this particular folder itself, I'm going to create a Docker file. Okay. So vi Docker file, enter. So now I'm going to write all the instructions that would be required for Dockerizing this particular application. Now basically it is a very simple application. Okay, so basically I would like to explain few things related to it. Package.json over here gives more information about your project. Okay, it mentions the dependencies that are required, the name, the version, description, main, and all of such things have been mentioned over here related to the project, which gives you more information about it, right? And this is the main file. Okay, so basically over here you are trying to get this particular library of express, okay, and you are uh, calling this particular function over here, which is also the constructor, we can say. And then uh, the port, the value we are assigning it to be 3000. Okay, then after this we have this app.get, okay, which is in the form of request and response. So these are few basic things which you'll understand if you have a good understanding of Node.js. So within Node.js we have such APIs. Okay, so this is basically the backend, and these are all the API requests, that is get, listen, right? And we are sending the response accordingly to on this particular request. Okay, so if we get the request for slash, this should be the response that we should be sending. Similarly, it should be listening on port. This particular port is defined over here, which is 3000. So the app is listening on port 3000. Okay, so remember, since it is listening on port 3000, it is important to expose the port 3000 on your container itself. And this is what you will be able to see in your console output once your app is listening to your requests. So the foremost thing is that you would require Node.js installed on your machine. Node.js should be installed in order to run this application. Definitely, right? So, in case of Docker, we don't install anything. What we do is we use base images. So, let us go to Docker Hub, okay? Here, let me sign in. So, yeah, I am inside my Docker Hub profile, okay? And over here, you can see multiple images over here, okay? You can search it and you can definitely use them as well, okay? So, in my particular profile, you can see these are few images which I have pushed, okay? So you can search anything for any image from here, okay? So I want an image for node because node will be forming my base image on top of which I will be running my application, right? So this is what is I'm going to search for. So I got this node over here, okay? I'll click on it. So these are the Docker official images, okay? And in here there are multiple tags, that is there are multiple versions of it, so you can use any among these. So I will be making use of a simpler kind of image, okay? So I'll keep it simple by making use of alpine image, okay? I'll use 24 hyphen alpine. So let's go over here, from node colon 24 hyphen alpine, okay? Then after that I will be kind of selecting a work directory. So this directory is inside the container, okay? It has got nothing to do with your local machine. It is completely isolated and it is virtualized, you would say, okay? So within the container we are considering a directory, that is app, okay? Now what you want to do is you want to copy package star.json to your app directory, okay? You are just copying it from your local machine onto your working directory inside the container, because you would require this package.json. Then the next thing that you would be doing is you are going to run npm install. I'm going to run npm install, okay? So with the installation of npm, what will happen is package hyphen log.json will be created, node modules will be created. So so all the required libraries will be mentioned within this folder of node modules. All the modules or the libraries will be available there. I will be copying everything, right? After doing npm install, I will be copying app.js, right? Once that is being copied, you would be exposing the port 3000, and the cmd command that you would be running over here is npm start, okay? Save it. Fine. So now if you do ls, you can see the docker file here. Now after this, once you have written the docker file, you can now execute the command, that is docker. But before actually building the image, what we would be doing is, since we want to store this image on our Docker Hub repository, what we are going to do is we are going to log in -u. Okay. Now the password is what I need to enter, and the login has been succeeded. Okay. So now I can push the image Docker repository. I will name it accordingly. So Docker build -t, the name will be Gauri 70, the name of my repository, followed by the name as my node app, followed by dot, which indicates the path of the Docker file. Enter. So it has started building the image, and all of these are multiple layers. Okay, each instruction will form a particular layer. So now your image has been created. So let's check. So over here you can see this image has been created over here. Now in order to push this image, okay, since this image is there, what I'll do is I'll just do docker push and the name of the image. So layer wise it is pushing the image. Okay. Okay. So now if I go over here and I go to my profile, let me go to my profile. Over here you can see my node app has been pushed to my repository, right? If I click on it, the only tag I can see over here is of latest. If I have not mentioned anything, it means automatically by default considers it to be latest. If I want to run this particular app container, so how can I do that? So you can do docker run the name of the image, right? Now since it should be running in background, I will put -d and -p for the port mapping. So basically in case of port mapping, what is the concept is, let me explain it over here. This is your host, right? This is your host, on top of which you have a container running. Now this container, if we are exposing 3000 port, it is opening this particular port of 3000. But this port needs to be mapped to this particular port so that we can access it on this host. They are isolated, right? These containers are isolated. In order to access them, you need to map this container port with your host port. So it should be mapped like this 3000 must be mapped with the 3000 of your host port. Okay. So in this way, you can map it and try to access this application. Okay. So let me mention it as 3000 colon 3000. Okay. And enter. Okay. Now let us check. It is in the running state. Okay. Now if I go onto my public IP, so over here this is the public IP, and I will try to access it on the port 3000. Then I must be able to kind of access this particular application. Let me check the security group as well. Okay. Yeah. So we haven't opened this port 3000, right? So we'll have to edit the inbound rules. Okay. Put the custom TCP 3000 from anywhere and save rules. And now if I try to access, you can see that I am able to access this particular application. So this is how we Dockerized this Node.js application. So that's why this was just crash course kind of a video, so that no one is left out, right? So for that matter, I have kind of introduced Docker in a better way to all of you, and now we are ready to go and understand Kubernetes. Okay, so I hope this video was very much helpful to all of you. I will be definitely adding this Docker file to my GitHub repository as well. So I will be updating this Git repo whenever I upload a video on this particular series. Okay, so do comment, do like, do share, and also subscribe to my channel so that I remain motivated enough to keep uploading the videos. So I hope this was really helpful to all of you. And thank you so much for staying till the end. And very less people who are really, really focused and who really want to learn will stay till the end. And I really appreciate that. So well done, and keep going, and you'll definitely gonna get a very good job. So I'm also going to make interview questions, prepare some interview questions on these concepts as well. So if you want a video on interview questions also, please let me know in the comment section, because that is the only way that through which we can connect with each other, right? So that's why I would just like to say, like, keep supporting and keep learning. Thank you so much.